Hi folks, here we're going to talk about the different types of connective tissues. And so we're going to first start with connective tissue proper here. We have loose and dense connective tissues. These are two subcategories of connective tissue proper. And so they're basically what the name suggests. Loose is loosely packed fibers within the connective tissue proper, and dense is more densely packed fibers in the connective tissue proper. So you can see all this pink is hundreds if not thousands of fibers all lined up, and here you can just see a couple strands painted and kind of thrown about here. There's a lot more white space, quote unquote, here in loose connective tissue than it is here. When I mean white space here, I'm just referring to the background here, which hopefully you remember is ground substance here. Just because it's white and clear doesn't mean it's nothing. There is fluid, ground substance is there. Alright, so we're going to start out with the loose connective tissue propers, and then we'll move on to the dense ones. So here we have areolar connective tissue. Areolar connective tissue here cushions and binds the organs. It really acts like the glue for a lot of different organs and tissues of the body. Wherever you see some type of tissue, there's bound to be some areolar connective tissue kind of holding things together, cushioning things. A lot of the body's water is held in this areolar connective tissue, in fact. Then you can pretty much, because this is such a ubiquitous tissue, you can find this tissue pretty much everywhere in the body. And this is a legitimate answer on a test. Now we have adipose connective tissue. Adipose means fat, so this is fat tissue. Of course, in class, we're going to call it adipose connective tissue. And so the function is to store store food fuels and protect organs. And then where can you find it? You can find it in various places. You can find it under the skin, around the kidneys, eyeballs, and within the abdomen. Just like the last epithelial tissue video, this is not an exhaustive list of functions and locations, but this is the ones I'm going to test you on. Here we have the reticular connective tissue, another loose connective tissue here. And the big thing about this one is it has a lot of reticular fibers. All of this is reticular fibers. So just a high density of reticular fibers makes it reticular connective tissue. The function of it is to hold and support other cells, which makes sense if you know the function of reticular fibers. And you can typically find this tissue in lymphoid organs like spleens or lymph nodes. Now we're going to move on to our dense connective tissues. And you can tell they're dense because it has the word dense in it. This is dense irregular connective tissue. Here, all this pink here are all the collagen fibers bundled up together. We have a lot of collagen fibers that's kind of bundled up. It's create all these kind of pink hues here. And so the function here is to withstand tension exerted in many different directions. So if you pull on this tissue in any different angle, it should be able to handle it pretty well. And the reason is because these fibers are pointing in all sorts of different directions. This is why we call it dense irregular connective tissue, because the patterning is quite irregular. It's quite random looking, right? But because the fibers are pointing in all different directions here, the tissue can kind of withstand strain in any direction. So you typically find this tissue where you need that kind of ability. In synovial joints, skin, and the GI tract. Think about your skin, it can potentially get stretched in any sort of direction, so it's important to have dense irregular connective tissue there. Now, kind of the opposite of dense irregular connective tissue is dense regular connective tissue. This is another dense connective tissue proper. And this time, the fibers are all kind of flowing in the same direction here. Here it looks a little wavy, but it's all going left to right or right to left, whatever direction you want to consider it. All the fibers are going in the same direction, so that's why we call it dense regular connective tissue. Here, because all the fibers are pointing in one direction, that tissue can then withstand tension in that one direction along the length of those fibers. If you pull in that other way, like in a perpendicular way, it's not going to withstand the stress very well. It's only if you apply that stress along the tension of the fibers. So a place where we need tissue to withstand tension in one direction tendons and ligaments. They are being pulled by muscles and bones in a very predictable pattern and direction. And so we'll see dense regular connective tissue in those places, in tendons and ligaments. Then we have elastic connective tissue. It is like dense regular connective tissue, but we have an abundance of elastic fibers. Whenever you see kind of dark purple strands, you should think elastic fibers. And so we just see a ton of elastic fibers put into this dense connective tissue here. So its function is to allow tissue to stretch and recoil. And so places you'll find this is the walls of arteries. We're done with our connective tissue proper. We're moving on to our cartilages. And our cartilages honestly look very similar from one another. And so you have to pay attention to the differences in the extracellular matrix to tell the difference between the three different types. So this is hyaline cartilage here. Hyaline cartilage has the same features. It has lacunae, it has chondrocytes within them, and it supports and reinforces areas of the body. And it's pretty stiff. You know, if you feel the kind of the bridge of your nose, if you feel kind of around your sternum, that's where you're going to find hyaline cartilage, and it feels stiff. That's what it's supposed to feel like. Where can you find it? Embryonic skeleton, covers of bone ends, and the trachea. Now we have fibrocartilage. Look at that extracellular matrix. We see these kind of squiggles in the line. And those squiggles in the line are not they're not different fibers. They are collagen fibers. In hyaline cartilage, just because you can't see it, doesn't mean it's not there. There are collagen fibers in that hyaline cartilage. You just didn't see them like you did before. Here, the density of collagen fibers has gone up so high, now you're physically seeing them. And so that's what we call fibrocartilage, because there's actually a lot of collagen in fibrocartilage. There's still some in hyaline cartilage, just not as much. So fibrocartilage, because of all this extra collagen it has, it gets to be a little bit more rubbery, so it can absorb compression shock pretty well. It acts like a shock absorber in ways, and so you'll find it in places of the body that need kind of shock absorbing abilities. So places like intervertebral disc and your knee joint, right? When you jump up and down, your knees take on a lot of shock. So the fibrocartilage is there to absorb that compression shock. Last type here, elastic cartilage. Last type of cartilage here is very easy to be identified because you can see those purple fibers within that extracellular matrix here, and that purple fiber is elastic fibers. So if you find elastic fibers in your cartilage, this is elastic cartilage here. And so function here, maintain the shape while allowing flexibility. You need an example of this? Your ear, right? Your ear is stiff, it maintains its shape quite well on its own, but if you bend it, it snaps back to place, right? So elastic cartilage is not found in many places in the body, really only two places, one being the ear. And so it's a pretty easily identifiable tissue here. Okay, folks, that's it for this video. You're done with the histology videos. If you watched the other three before this, I'll see you for the discussion.